Good morning. I am Aher from RBNB College, Rampur, from Physics Department. Today we start the chapter Gravitation. In this chapter we see the Earth satellite, then projection of satellite, and then the projection of satellite, the cases. Now here we see the satellite. What is satellite? It is for example moon. Moon is the satellite of the earth. Now there are two types of satellite. What is the earth satellite or satellite? It is the object revolve around the earth. It is called as satellite. There are two types of satellite. First natural satellite, then artificial satellite. Now moon is only a natural satellite. Moon revolves around the earth. It is called as satellite. It is a natural satellite. Now artificial satellite. There are different types of artificial satellite. Artificial satellites are the man-made satellites. Man launch the satellite into space, and such a type of satellites are communication satellites. It is also called as geostationary satellite. Polar satellites are the artificial satellite. Now what is the use of this satellite? There are different types of satellite: communication satellite, polar satellite, geostationary satellite. Communication satellites are used for the communication purpose, that is weather forecasting, then meteorological purposes, then television broadcasting. Then the satellite, geostationary satellite, it is having the period 24 hours, that is 1 day. The satellite revolves around the earth with the sense of Earth's rotation, and the period of this geostationary satellite, it is 24 hours. Now the polar satellite revolves around the earth for very short kilometer, that is 500 kilometer to 800 kilometer. These are all about the satellite. The satellite revolves, or it is the object revolve around the earth. There are two types of satellite: natural satellite, then the artificial satellite. Moon is only natural satellite, and artificial satellites are communication satellites, geostationary satellite, and polar satellite. Now we study how to launch or how there is a projection of satellite. Now consider there are two stages. In first stage and in second stage. In first stage, the satellite placed on a tip of rocket. Now suppose this is satellite, this is rocket, then satellite is placed on the tip of rocket. Then the fluid is burned, and the satellite is taken at the desired height above the earth's surface. Then this satellite is rotated through 90 degrees, and first stage is detached. Now in second stage, the satellite is rotated, or it is given to the horizontal velocity given to the satellite, so that the satellite revolves around the earth, and the velocity, it is called as critical velocity or orbital velocity. At the second stage, a horizontal velocity of the projection is given to the satellite, so that the satellite revolves in a circular orbit round the earth in a same sense, or it is called as critical velocity or orbital velocity. Now we see the different cases for the launching of or the projection of satellite. Now see the picture, see the figure. In this figure, see there is the earth. This is the elliptical orbit, then this is the circular orbit, again there is the elliptical orbit, then parabolic orbit, then hyperbolic orbit. Now see, we discuss the different cases when the satellite revolves around the earth. If case first, when the horizontal velocity of projection is less than critical velocity. We know critical velocity, it is the certain maximum velocity or certain minimum velocity when which or through which the satellite revolves around the earth in a circular orbit. Now if this velocity, that is if the tangential velocity of projection Vh is less than critical velocity, the satellite moves in a elliptical orbit. See, when the velocity of projection is less than critical velocity, satellite revolves in the elliptical orbit. In the elliptical orbit, or satellite is in ellipse with the point of apogee, that is it is fastest, it is longer distance, it is fastest from the earth's surface, and the satellite revolves or it is in the earth's atmosphere. As a result, there is a loss of energy and it is spiral down. This is the first case. Now in second case, see, in second case, when the velocity, horizontal velocity of projection is equal to critical velocity, satellite revolves in a circular orbit. See, in second case, the horizontal velocity of projection is equal to the critical velocity. The satellite revolves in a circular orbit. That is, the critical velocity, it is the velocity the satellite revolves in a circular orbit. In third case, that is the horizontal velocity. This horizontal velocity, it is greater than critical velocity but less than escape velocity. What happens? Then the satellite revolves in an elliptical orbit again. See, in third case, or when the horizontal velocity of projection is greater than critical velocity but less than escape velocity, the satellite moves again in an elliptical orbit. See, in this case, the velocity, horizontal velocity is greater than critical velocity but less than escape velocity. The motion of the satellite, it is in the elliptical manner, in the elliptical orbit. Now the next case, in next case, the velocity of projection of the satellite, it is equal to escape velocity. What is the escape velocity? Escape velocity, it is the minimum velocity with which the satellite revolves or it is free from the earth's gravitational field, and the satellite is given, see here, horizontal velocity of projection is equal to escape velocity, satellite revolving in a parabolic path. See here, see, the velocity of horizontal velocity of projection is equal to escape velocity, satellite revolves in a parabolic path, that is it is free from the earth's gravitational field. And the last case, when the velocity of projection, it is greater than escape velocity, the satellite escapes from the earth's gravitational influence in a hyperbolic path. See, when the velocity of projection is greater than escape velocity, the motion of satellite, it is hyperbolic path. See this motion, this shows the hyperbolic path, and this all about the cases of the projection of satellite. See again, when the first case, if the tangential velocity is less than critical velocity, then satellite moves in an elliptical orbit where the point of projection, it is at apogee, that is from it is fastest from the earth surface or from the earth, and the satellite, it is through the atmosphere, and as a result there is a loss of energy, the satellite spiral down. That is, say next case, when the horizontal velocity is greater than critical velocity, the satellite revolves in a circular orbit. Then if the velocity of projection is greater than critical velocity but less than escape velocity, it is again elliptical orbit. When the horizontal velocity is equal to escape velocity, the satellite moves in a parabolic path. and the velocity, horizontal velocity is greater than critical velocity, escape velocity, the satellite moves along, travel along the hyperbolic path. This is all about the projection of satellite. Thank you.